everyone, and welcome back to the Water Online Show, powered by Water Online, the leading online destination for the water and wastewater market. I am your host, Travis Kennedy, joined as always by my colleague and friend, Mr. Worldwide, Kevin Westerling, chief editor here at Water Online. Kevin, heck of a show we have lined up for everybody today.
Sure do. Excited about it. Good to be with you.
Well, I mean, we've been talking about this for a long time, and it's really gaining steam as we roll into 2026. So just to give a point of emphasis on what the data says. So the topic we're going to be discussing today is water sustainability in data centers. And if I was to pick out one piece of data to sort of start off our conversation, it would be that a single large data center can use millions of gallons of water per day. That's millions with an M. So it often rivals the demand of a small city. As cloud computing and AI accelerate, the water footprint is becoming impossible for utilities to ignore. In today's episode, we're going to explore how the rapid expansion of data centers is really and completely and entirely reshaping local water demand. The pressure it also puts on infrastructure and supply planning, and also how utilities and operators are working to manage the growth sustainability. So there was a paper that recently put out by our guest, who I will introduce in a minute, called Water Sustainability in Data Centers, and it addresses the urgent need for smarter, more sustainable water management as AI accelerates data center growth across the entire globe. And here to tell us more and answer our questions about data centers, water usage, and AI itself, Rob Collier, Group President of Water Treatment at Veralto and former President at ChemTreat. Rob, welcome to the Water Online Show.
Hey, Rob.
Thanks, guys. Happy to be here.
So I want to roll right into the very first question here. And it's going to start with where we start a lot of conversations these days, which is around AI. So AI in and of itself, everybody knows kind of what it is conceptually, but it's experiencing incredible and exponential growth, and it's being utilized in all aspects of industry, society, the world as a whole. What does it mean specifically, though, for the water sector?
Okay, let me think of where to start there.
Right.
First, I would get back to impact, just to put this all in perspective. You talked a little bit about this at the beginning, but I think AI growth has the potential to significantly improve human life. So it's very much a positive development for society, but you've got this big environmental impact or potential for a significant environmental impact. As you've got this new wave of high density computing, higher chip density means more heat generation, which puts more pressure on cooling systems in local water infrastructure, not to mention the power supply. So water and power now become gating factors for this great thing, or what could be a great thing in AI growth. And I think that creates a huge opportunity for the water industry to step up and help data centers manage this difficult balance. So we've got to find a way, and we are, of equipping data centers and utilities with solutions to support a more reliable water supply and drive a more efficient usage of that water. So we're approaching it very much from the standpoint of, let's not limit the growth, let's solve for the gating factors so that everybody wins here.
So I just want to expand upon that real quick with a question about when is an appropriate time then for a municipality or a city or any kind of water system to start thinking about and getting in touch with those that can help them with what's going to be, of course, a rapid increase in demand? Like, what are the triggers for that? When do they start looking?
I mean, look, I think you'll see as we get through the discussion here, that's one of our biggest learnings and one of my most stressed recommendations, which is you can never start talking about it soon enough.
Yeah.
So we've taken over treatment at plenty of data centers where it was clear that this wasn't thought about at the outset. And as you might imagine, it's actionable, but a lot more difficult after the fact to begin limiting the impact here.
So, Rob, how much water are we talking here? Maybe not specifics, Travis, mentioned how much water these data centers take. I've also seen data centers being built in like what are already water scarce areas. So if water is one big pie and data centers keep cropping up, are they really infringing upon the water supply and the utilities' ability to get water out to consumers? Like what chunk of water, available water, are these data centers using?
I mean, that's a very difficult question to answer, Kevin, because there's so much variability based on the design of the data center and where it's located. I would tell you just an absolute amount, even with all the variability. Travis touched on it at the beginning. I mean, you've got just a small 15 megawatt data center can consume the equivalent of an 18-hole golf course for the year. And a 100 megawatt data center, that's 1 million gallons a day, almost 400 million gallons annually. And so you're talking about significant withdrawals if there isn't some sort of treatment intervention in order to limit the impact, particularly in certain regions where these data centers are cropping up.
Yeah, they're cropping up everywhere. Like this is not just something that's slowly being rolled out in various places every now and then, randomized across the country. They're being rolled out in mass because everybody's getting in on this AI development, right? So the fact that it requires that much water has to come from somewhere. And I'm curious in terms of like water types. So what are the types of water and the various water treatment requirements in data centers? So let's try to get a little bit more granular about what they use, what types of water and how that works.
Yeah. Well, look, I'll speak in general terms here. You've always got the source water that's coming into the facility. That's coming from a municipality or groundwater, surface water, or in increasing number of scenarios, reclaimed or recycled water. And that's got its own host of treatment requirements. You've got pre-treatment to remove contaminants and ensure compatibility with the cooling system and the other surfaces once it enters into that data center. Now you have your conditioned source water. Now that becomes the utility water that's used throughout the facility, primarily for cooling, but also humidification and cleaning. And that, again, needs ongoing chemical conditioning to prevent scale, corrosion, biofouling, all of the required treatment so that you can maximize heat transfer while protecting the assets in that facility. Then you've got the liquid cooling systems. This can tend to be newer technology, but things like direct-to-chip and immersion cooling to further improve the efficiency. These are all in the name of finding, if it's primarily used for cooling, what's the way that I can reduce the water required and or the power required in order to get the outcome here. And then lastly, you've got wastewater. So primary wastewater stream is cooling blowdown. That's going to be concentrated with dissolved solids and treatment chemicals and organics. And you need some treatment technology there as well in the form of separation and filtration, UV disinfection and contaminant destruction, and then chemical conditioning of recycled water to reduce overall water consumption.
Mm-hmm. And are there any regulations? I'm unaware of federal regulations. I'm sure wastewater, as you referenced, needs to be treated before discharge. But like even on the scarcity side of things, are there any state or local regulations that might say you have to reuse the water or anything like that to try to protect the supply?
I would say indirectly. So if we're talking about the U.S., the regulatory focus is primarily on wastewater. And the federal oversight part of that comes through the Clean Water Act, which set the effluent limitation guidelines. And then the states take it from there through the NPDES discharge permit process. So the state and the local regulations govern withdrawal limits, discharge chemistry, and stormwater. And, to answer your question, it's pretty dynamic. So water-stressed regions may impose consumption limits or require reuse where others don't. And then we see areas where regulation is tightening as communities become aware of the AI-driven water demands. So compliance with all of this emerging regulation requires really close coordination with utilities and in the environmental agencies.
Mm-hmm. It's weird that regulations are different across the country for different areas. That just seems to be in lockstep with, a lot of other areas of which regulations like to get involved in, right? So it's kind of it's something to talk further about as it relates to different regulations for different areas of the country. But I want to kind of put regulations to the side for a minute. I know we're a regulatory-driven industry, but just for a second, just for kicks, let's put regulations aside and let's talk about best practices and what's practical. So if you could have an open floor, Rob, about giving our listeners and our viewers what the water treatment best practices are in terms of, say, cost efficiency, sustainability, environmental responsibility, which is a big topic that we've talked about here on the Water Online Show. What are some of those best practices?
Let's start with the basics.
Great.
So, you've got kind of the foundational components of good water treatment, and then you've got new innovation that's on the horizon. But if you just start with the basics, it starts with the closed loops. That's where you're driving all of the critical heat transfer that allows for the cooling mechanism of the servers. That is the whole reason that water and energy is being used in these data centers. So maintaining a really high quality water in the closed loops to protect the cold plates and improve heat transfer is critical. You move out from there, now you've got to optimize the cooling tower chemistry to protect that cooling system. It's maximizing uptime, also maximizing the efficiency of heat transfer and getting the most out of that cooling system in order to reduce water usage, which allows you then to get to the next part, which is reduce blowdown volumes by employing these advanced treatment and monitoring programs. And then last, I'd say, ensure that the systems stay clean. That further reduces energy usage and overall water consumption. And you've got to have a really good monitoring and control program that's tracking performance continuously so that you can intervene immediately if any of that treatment gets off track. So sounds pretty basic. For anyone in our industry, they might view it that way, but I would say start where you're at. I mean, we've gone into existing data centers and applied these best practices without any groundbreaking new technology or investment, just application expertise and program discipline. And we've reduced blowdown water by 20%. We've improved power usage efficiency by 10%. And I think that's a really good start in terms of reducing environmental impact while meeting the emerging AI demand.
Right. And as you speak of the emerging demand, as you were just saying, we have great technologies now that can help mitigate water impacts. But as AI continues to just grow and grow and grow and computing power gets even, stronger, these water impacts will be felt even more. So are there any innovations that you see on the horizon that you've been researching or working on that give you optimism that the water tech industry is always innovating, right? So is there anything that excites you about the future?
Well, yeah, of course, we've got a great deal of excitement about the future here. I mean, I think you need to elevate up a level, and I would view it like this. You've got it's kind of pick your challenge here. What's the limiting factor you're going to solve for? Certain approaches to cooling methodologies create far greater power and footprint demand, and then certain approaches create far greater water demand. So our goal here is choose the ones with the greatest water demand so that we can kind of take the footprint and the power issue off the table and then solve for that through some of what I've mentioned already around continuing to advance the chemical monitoring and control program for these cooling systems. If you can stress the cooling system to a higher level while not damaging capital equipment and not compromising on heat transfer efficiency, you're reducing the amount of water that's required for some of the more conventional systems. Obviously next, which it's not, I wouldn't call it a brand new innovation, but it still hasn't fully caught on at the scale that we would expect to see, is adopting water reuse methodologies, either directly at the data center site or wherever the source water is coming from, so that we keep reducing the demand on fresh water supplies. That's kind of, how do we just take what's, for maybe to use some lazy verbiage, kind of the known approach, and make sure that gains traction at a greater scale. And then you've got these advancements in the actual cooling technology, what's occurring at the server. So you might have heard of direct-to-chip liquid cooling or immersion cooling. That's allowing for step function changes in server cooling efficiency. So as opposed to air cooling a data hall to cool the servers, just like air conditioning cools us, you're directly cooling hot components of the server, or actually immersing the server itself in a fluid. So much more efficient, but also, more costly from an upfront capital perspective. And then they require extremely high water quality and specialized treatment protocols. So that's how we view it. If I were to build on it from there, I'd just tell you the last and most important part, which is some of what we started with, is not much of an innovation, just more of an evolution, which is that the closer integration between chip design, site design, and mechanical engineering and water treatment, is becoming increasingly critical. So in the past, the water was somewhat of an afterthought, leading to inefficiencies and costly retrofits. Now, proactive integration between these disciplines is enabling smarter, more resilient data center infrastructure. And I think you'll start to see that results in much broader adoption of some of the innovation I just talked about.
It's a team sport is what I'm hearing, right, Rob? It's a team sport. Everybody's kind of starting to work together and rowing the boat at the same time to get this moving and correct the problem that is quickly becoming very visible to the industry. So I mentioned in the beginning of this episode what most of our listeners already know, and that Water Online in and of itself is the leading online destination for if water solutions providers would want to connect with municipalities and consulting engineering firms and show them what their solutions can do. We are the first stop for that, and as well as having engineers and operators come to Water Online to take a look at what solutions are out there and what those solutions providers are actually doing and offering. So I know that in this particular section and sector of the market, it's becoming more and more of a big play, right? So from a private industry standpoint, how can PI and water solutions providers help water utilities challenged by the demands that data centers are creating for them on top of the already existing consumer demands?
Yeah, it's a great question. I would get back to how we started, and I know it's sounding like a broken record here, but believe it or not, this wasn't the norm even a couple years ago. So private industry and the water solutions providers need to start the engagement early so that the utilities can plan for the water and discharge needs.
How early? I'm sorry to interrupt. How early?
I mean, every project timeline is different, but it would need to be right up front as they're beginning to plan out these investments and get approvals for such projects and expansions. But in doing so, I think it's critical that they provide accurate load forecasting and water quality expectations. And then that allows everybody to move in lockstep towards the final objective of designing treatment programs that are sustainable and drive efficiency while improving discharge quality. And depending on the size and where it's at, that could just be a disciplined application of current expertise and best practices, or in more water-stressed regions, needing to begin to adopt some of these other innovations or a reuse methodology that's more than actionable if you've got the time to plan it out and get the investment to do so. But overall, I'd say you talked about a team sport. We genuinely believe that if we work collaboratively, we can build infrastructure that benefits both data centers and the community. So I realize it's a lot to digest here in a short amount of time.
We specialize in that. We just throw everything we can. We have a very highly educated in terms of knowledge of this industry audience. So I wouldn't worry.
But I like the way you phrased the last question, and you talked, and then you qualified earlier my comment says this being a team sport. The challenge of enabling the growth and benefits of AI while also protecting the environment is for private industry and water solutions providers, and to some extent water utilities, to solve for our communities. So we're in it together. If you're listening to this and want to know how to get started, reach out to us. We've got the expertise to solve these issues, or at least point you in the right direction so that we can get better together.
So, Rob, we always like to end these episodes and these segments on the best next step. So what would be the best way for our listeners and our viewers to get in touch with you if they have more questions about the topic that we talked about?
Yeah, look, this is a space that's unbelievably important to our portfolio of water treatment companies at Veralto. I'd tell you as a start, the two that play most centrally here are ChemTreat and Trojan Technologies. This is our specialty chemicals and services business, and our UV disinfection and contaminant destruction business. Reach out to them. Their information's broadly available, and I've got high confidence that they'll be able to point you in the right direction to get you the answer you need.
You can also reach out to us directly here at the Water Online Show, and we can also make sure that we get that request or any questions that you have over to Rob and over to Veralto directly. So Rob Collier, Group President, Water Treatment at Veralto, I want to thank you for joining us here today and helping educate us, Kevin and I, and our audience on not just what comes next in the world of data centers and water reuse, but where we are now. So we certainly appreciate it, and I can't wait to have you back in the future.
Yeah, thanks Travis and Kevin. I appreciate it. It's been great. Thanks for having me on.
And for all of you out there, thank you for spending your time here with us. On behalf of Kevin and I, we cannot wait to catch you next time here at the Water Online Show.